Hi, in the upcoming set of videos, I will demonstrate how to implement OFDM using antennas on RFSoC. The first step is to download the base code. The base code that we'll be using is on the Meow Lucian GitHub profile. He has implemented OFDM 802.11a on SDR. Firstly, we will download the code and extract it. Now, once the code is downloaded, I will extract the file. I will choose any location. By default, I will put the file in the folder where my block diagram is situated. In the MATLAB folder where my block diagram is placed, I will place this file. Now, once my file has been extracted, I will firstly rename it to make sure there are no decimals. And now I can start working on the code. The first file that we will be working on is OFDMTX. In this file, we have the transmitter code. Now, this is the OFDM transmitter. This OFDM transmitter, when we come to line 31, we can see the frame. The frame is constructed by concatenation of short preamble, long preamble, and the data that has to be transmitted. Then the frame is oversampled. When we oversample and the oversampling factor is 2, every sample is succeeded by a 0. After that, it is passed through a root raised cosine filter. The filter will introduce 12 symbols, which will be placed such that first 6 symbols are placed of the coefficient of the filter. After that, the signal will be placed, which was obtained after oversampling. And again, the last 6 symbols of the filter coefficients will be placed. And that the signal that we will obtain after convolution, we will save that signal. We will also save the data that we originally have. So now we have saved the data that we originally have. We had data payload 1 and data payload 2 that we have now saved. So the changes that we had to do in OFDM TX are now done. The first objective is completing MATLAB loopback for oversampling factor equal to 2. The next change that we will do is in the hardware TX file. In the hardware TX file, firstly we will call the code OFDM TX. Now after that, since this code has been implemented on SDR, which is different from what we want, this has been implemented on Z-board and some analog front-end device. But we are going to use the RFSoC, hence these hardware parameters are not required for us. Also, these button settings are not required for us right now. So I will just delete all these parts. I also won't be using the state and the way this code has been run. I will be using a simple for loop. Inside that simple for loop, I will try to record 3 frames and try to check if I can see the packet fronts of those 3 frames. I will just increase the number of samples to any arbitrary number. Just keep it around 60,000. Now the next part comes with hardware RX. In this RX file, I do not need to again call global parameters and clear and close all because all the content I will copy to hardware TX so that I have a single file. I will again remove the button settings and also the hardware parameters since we are going to use a different SDR. I also don't need the ready time. And as I said, I will be using a for loop to run the code. So the while loop will be removed. I will use a for loop. I will keep the space to the iteration frequency very less, and the maximum size up to which I will go is the data that is being received. Again, the way that the code is originally being run, I will remove that and I will just use a simple for loop. Now I will copy this entire code and put it in hardware RX so that I have a single file. I don't need 2 files to run a simple MATLAB loopback. And for now, I will put the scale to 1. Also, this file is being read and the content of this file will be plotted. So directly this file can be this vector that we have created after repeating the original signal that can be used. Initially, I just want 3000 samples of my signal. Why am I using 3000 samples is that since a size of single frame is 972, so I am sure that in 3000 samples, I will at least get 3 frames. So that is why I'm using 3000 samples at one go right now. Also, in my for loop where plotting of the data is being done and OFDM RX is being called, I need something called RX object dot baseband sample rate, which is defined in my global parameters file. When I see my global parameters file, this is where this property has been defined. So firstly, I'll take this RX object and this object I will define as the global parameters object. And the baseband sample rate property I will define as the global parameter bandwidth. And now with these settings, we are ready to go for MATLAB loopback. And if I run the code, I can see that the MATLAB loopback has been executed. So this was the part 1 of the video where we are just executing a simple MATLAB loopback for oversampling factor equal to 2. Thank you.